Okay, guys. So I'll be carrying on today's discussion. Uh, so firstly, I'll share my screen. Okay. So is my screen visible? Okay, it's visible. It's the first question. Turtle and Piggy are playing a game. So basically, what we have is that Turtle will choose an integer x, and that x will be within a range L to R. All right. L and R will be given, and also there is a further constraint on L and R that R is at least twice of L, and after that, Piggy will keep doing this operation until x becomes one. So Piggy will do is that he will choose an integer p such that p is at least two and x is a multiple of p. So basically, and then set x to x by p, and the score will increase by 1. So what this operation basically means is that we will take a factor of x such that it is at least 2, such that the factor is at least 2, and then divide x by that particular factor, and after that we'll increase the score by 1. Okay, like for each division we will be increasing the score by 1, and like initially the score will be 0, and what we have to do is that calculate the maximum score. Okay, so like this question is pretty simple actually. If you think about this, like if we want to maximize the score of uh, mm, of this game, then what we actually have to do is that divide this x by p as many times as we can, right? So let's say if uh, x becomes x by p, and like if we want to keep doing this operation again and again, then like we must be able to choose the smallest possible value of p, right? Like we must always choose our x such that we can divide it by the smallest possible value of p the maximum number of times. So in this case, if you think the minimum value of p will be 2, right? So if we are to divide this x as many times as we can in order to maximize our score, like we can think it in terms of representing x with powers of 2 only. So like if our x is 2 to the power k or something, then we can divide it like the maximum number of times, right? And thus our score will be maximized as well. But if you think, let's say we choose x as some power of 2, and let's say someone else chooses x as a power of 3. So now if you think about this, and the constraint is that this will be in between L and R, right? Let's call it K1, let's call it K2. So if you think about this, like in terms of like if we express x in terms of the powers of 2, or as in terms of power of 3, or let's rather think of it. So let's think of it in terms of multiple factors. Let's say it is power of 2's number of times, and then there is power of 3. So like these are the basic prime factors of x. So if you think about this, that if we are to stay within this range, and we have to keep a value of x which will let us divide x by its factor the maximum number of times. And within this constraint, like, would this not be beneficial that after we get x equals to 2 to the power k1, if we had multiplied it further with 2 only, then we might have been able to like get to a bigger value. Like, let's say we have y equals 2 to the power k1. Okay, and let's say if we had divided 2 here, sorry, if we had multiplied 2 here, then we would have gotten some value, right? But instead of 2, if we multiply 3 or some other number, 4, 5 or anything, then what will happen is that, like, if we multiply 3 to 2 to the power k plus 1, then that will give us a value which will be greater than 2 2 to the power k plus 2 to the power k1 into 2, right? So, like, if we are to keep x within this range and also maximize this k1 number, right, then it will always be beneficial to keep multiplying this with 2 until and unless the value of uh, like the value of our x is less than r, right? So what we can simply do is that in order to find this, let's say the input given to us, the input is t, the number of test cases, and then we have l and r, the ranges, right? So if we simply think of it in terms of r, right, if we just see that what is the value of uh, x, that, like, if we keep x initially as 1 and then keep multiplying 2 until and unless we are just less than r, like the value of x at which if we multiply 2, then that will become greater than r. If we just keep doing that, in that case, like, the number of times you multiply, that will be our maximum score, right? So basically this question boils down to taking log of r. And as you can see in my code also, that's what I've done. Like, I've taken the number of test cases as an input, and then n and m, which basically represents l and r. And after that, as you can see, my answer is log 2 of m. So, like, this log 2 is a built-in function, and, like, I am simply taking log 2 of m and then printing the answer. So, like, this was a pretty simple question. I hope all of you have understood it. So if there are any doubts or anything, you can, you have written something. The number line between number of prime numbers is maximum according to this. Yeah, it's correct. Yeah, such that its prime number. Yeah. It's correct. Like, it should be a product of prime numbers. Basically, uh, we are looking for its prime factorization only. Yeah. Okay, so, like, if anyone else have any doubts or any other approach, uh, then we can go through them in the chat box. Otherwise, I will be moving on to the next question. Okay. So we'll be moving on to the next question. Yeah, in teacher, log x by log 2. Yeah, you can do this as well. But yeah, you have typecasted it. It's correct almost. Just see that issue might come, like, because this log, like, this returns value in double, and then you are dividing this by this, and then you are typecasting that to integer. So sometimes what problem happens is that like, you like, when you get the answer in double and then you are typecasting it, sometimes like, that estimation goes wrong. Like, sometimes you get a greater value, or sometimes the value undershoots by one, or sometimes it overshoots by one. Yeah, that happens. So instead of this, like, whenever you are, like, having a logarithm, whenever you are doing log 2, then you can use this. log2. This function is inbuilt in C++, so you can use that, and that will return a correct answer in most cases. Okay, so now we'll be moving on to the second question. And like while I'm reading the question, you guys may mm, like use the chat box and share your approaches. And after reading the question, I'll come back and see like what approach you guys have had for this question. Like it doesn't matter where you solved them or not. Like whatever your approach was, you can just write that in the chat box. So turtle and an infinite sequence. So there's a sequence a0, a1, a2 of infinite length, and initially ai is equals to I for every non-negative integer I. Okay. So after every second, each element will simultaneously change. So ai will basically become ai minus 1 or ai or ai plus 1. Okay, so like this is the bitwise or, and after that we have to find the value of an after n seconds. In particular, if m equals to 0, he needs to find the initial value an. Okay, so basically we have the number of test cases, and then we have two integers n and m, where both n and m could be as much as 10 to the power 9. Okay, so basically what this question is, like you have an array, an infinite sequence. Uh, so initially ai is equal to I itself, and after every second the value of ai will change, and the new value will be ai minus 1 or ai or ai plus 1. So like every value will will go through a bitwise or with the two of its adjacent elements. Okay, so and what we have to do is that we have to process these queries, and the queries will be given in n and m. So like we have to find the value of an after n seconds. Acha, what is Acha, I'll come back to that later. Let's get through this question first. So basically that's it. So now let's pick up this test case to explain this question. So what we have here is n equals to 5 and m equals to 2. So if you consider 1, 2, 3, 4, seven. Okay. So if we just focus on 5, okay. So what will happen after 1 second? So 5 will become 4 or 5 or 6, right? And what will happen in the next second? Acha, you also have to consider this element and this element as well. Like what will happen to them? So 4, acha, this is 5, and 4 will become 3 or 4 or 5, and similarly 6 will become 5 or 6 or 7. Okay, so this happened at m equals to 1. So at m equals to 1 second, this is the scenario, right? And so what will happen at 2 seconds? At 2 seconds, we will have OR of all these three numbers, right? Acha, now you must know one thing about bitwise OR, that n bitwise OR with n will always lead to n, right? So if you think about this, okay, see here we have 4, here we have 4, okay, we have 5 here, 5 here, and 5 here as well, 6 and 6 as well. So like we don't need to like keep all of them multiple times, right? So like if we like bitwise or n any number of times, we know that the answer will be n. So we can just count them once. Okay, so this the answer will become for m equals to 2, 3 or 5, 3 or 4 or 6. Okay, so it's basically the or of 3, 4, 5, 6, and 7. Okay, so when is this? This is at m equals to 2. So like if you notice a pattern, right? For n equals to 5, at m equals to 1, what did we have? We had 5, 5 or minus 1, and that odd with 5 plus 1. Okay, now at m equals to 2, what do we have? We have OR of all the consecutive numbers from 5 minus 2 to 5 plus 2. So let's say we have m equals to k. So then for any value of m, any value of n, what would we have? We would have this, right? Like what we noticed was that uh, at m equals to 1, we are like taking all of the numbers from n minus 1 to n plus 1. For m equals to 2, it was n minus 2 to n plus 2, right? So it makes sense that at m equals to k, it would be from n minus k to n plus k, right? And yeah, we also need to consider one thing, that when we are at a0, right, the first element, then that will change only to a0 or a1. Okay, so we are not going to the negative side. So if this n minus k, if this turns out to be negative, then that will be cancelled off as 0. Okay, this thing we have to notice as well, this we have to keep in mind. Okay, so now if you think about this, then there is also another thing. Okay, let's say if we are taking the bitwise OR of a number of elements, then what do we know? Like 1 odd with 0 is 1, and 1 odd with 1 is also 1. So at a particular position, if we take OR of let's say 4 or 5 numbers, then we know that if at a particular position uh, that particular bit is set in any, like that particular bit is 1 in any of the numbers, then we know that in the final answer that bit will be set also. Okay, so what this question actually like acha, so like yeah, let's consider that test case only 5 and 2. Acha, so if I think of this, like what is 5 minus 2? 3. So 3 can be represented as 0, 1, 1. Okay, and then what do we have? We have 4, and then we have 5, then we have 6 and 7. So if you take the OR of all these numbers, see here we have a set bit of 1, here also the bit is set. So like since these two are set, we know that in the answer these two positions will be set. Okay, and as you can see at this number, we have this position as set. So in the answer this will also be set. And what is, and this is 7, right? And as you can see also for the fifth test case, the answer is 7. So now if you go for a bigger example, let's say 20 and 3. Okay, so like in case of 20 and 3, what do we have? We are taking OR from 17 to 23. right? So we'd be taking this OR for all the numbers from 17 to 23. So, like what you can think of, the binary of 17 is this. Okay. So now, if instead of like taking all the numbers, like looping through all the numbers from 17 to 23, and like taking all of them, like in a loop, like that time complexity will be big O of n, right? But according to the given constraints, n and m can be as big as 10 to the power 9. So obviously that will result in a TLE. So if I try to optimize that approach, uh, so what I need to think is that, achha, I can see that this bit is already set, right? So if I go to this bit, and if I think that is there a number between 17 and 23 which has a set bit in this position, if I think of that, okay, and like if I have a way of saying like does such a number exist or not, then I can like take my answer. I would just create an answer, uh, let's say an array where I will store key whether the ith bit of uh, my answer is set or not. See, like the lowest number is 17, right? In if n is equals to 20 and m is equals to 3, then I know that the lowest number in my range is 17, and 17 is this. Okay, so I know that this the number of bits that are 1 in 17 will obviously be set in my answer also, right? So now if I think of this bit, okay, so what can I do is that like I need to increase 17 by the lowest possible number, and I have to find out whether this bit is set or not. So what I can do is, since this bit is set, I can make it to 0. Okay, then I will set the other bit, and then I will keep the rest of that same. So now I will find the the decimal representation of this number, and then I will check whether that lies within 17 or 20, 17 and 23 or not. So like if you do this, it will be 18. Okay, and 18 lies between 17 and 23. So what I can do is simply go to this answer array and set this bit to 1. Okay. Now for the next bit, like that is what I'm going to do again. Set this to 0 and set this one. So let's do it again. 1 0 1 and all of them 0. Okay, so like I will set this bit and put all of them as 0. Okay, so now what I will do is that I will check again whether this number uh, lies between this range or not. So this will come out as 20. So yeah, I know that this can be done also. So I will mark that as 1 here. And let's say if I go for the another number, this becomes 0 and this becomes 1. So this number will turn out to be 8. So this will turn out to be 24. So 24 is greater than 23. So of course I cannot have this in my answer. So this won't be a part of my answer. And after that, I have all the bits as 1 only. So as you can see, so this the decimal representation of this will be my answer, and this comes out as 16 plus. So this will be 23. Okay, so like this will be my approach. Like for any given value of n and m, I will find out what is the minimum value of m that can be there in my range, and what is the maximum value. The maximum value will of course be n plus m, and the minimum value will be maximum of 0 or n minus m. So like in case n minus m is negative, then I will consider the minimum value to be 0. uh, and of course the maximum in my range will be n plus m, of course. Okay. So this is what I will do, and after that I will start off with the minimum value. So as you can see here, we started with 17. We'll make an answer array which will store all the bits of this minimum value only. And after that, what we will do, we will like loop through this particular thing, like this particular answer array that we have got. Sorry, this particular like the minimum value that we got, we will like loop through all the bits of that thing, and like we will for each bit that is 0, we will set that bit as 1 and set all the other bits to the right side of it as 0, and then we will find out whether that lies in our range or not. If it lies, then we will set that bit in our answer array as well. Okay, otherwise we will not. And after a position where there are no other bits which are 0 on our left hand side, after that we can just skip the process. Okay. So this will be my approach to solve this question. So now what will be the time complexity of this? As you can see, the range of n and m is 10 to the power 9. So at max there will be 32 bits in my binary representation. So for each test case, I am basically going through 32 steps, right? It is a constant amount of time that I am taking. So the number of test cases is t, and for each test case I'm taking a constant amount of time. So overall time complexity of my code will be big O of t, and t is 10 to the power 4, so that is well within the range, right? So now let's get through the code. So what we have here is that like I take in the input of the test cases, then I take in the value of n and m. So after that what I do is that I take the maximum of 0. Acha, हाँ, yeah. This is a point that you have to remember. As you can see that I also had this wrong answer on some pretest cases because no, not this one. Hmm. See, the problem that was happening is that when I was doing the left shift, then I was not using the long operator, right? So in that case, sometimes you will get an overflow error. So that is something that you have to be careful with. So that was just a heads up, and yeah, let's go through this code now. So what I do is that I initialize a vector of in order to store the bits, and like I take the left hand side range as maximum of 0 and n minus m, and the right side range of n plus m. So after that, like this while loop, what it does is that like it basically converts this L into its binary representation, and after that it stores that into this bits array. Okay. So after that, we also define an answer array which is initially equal to bits, and then we loop through this bits array, and like if the position is 1, if that bit at that particular position, ith position is 1, then we set it to 0. Otherwise what we do is that we calculate the value of the bit at that particular instance, and then we add 2 to the power I. Okay, so what that basically does is that if I'm at this index and I want to set this bit to 1 and then calculate the value, so that is basically the value of this like this number right now plus 2 to the power I, and I is like whichever position that I'm trying to set the bit as 1. So that's basically the calculation, and then I'm checking if the value is less than equals to r or not. So if it lies within my range, then I simply set that bit in my answer array as well. And after this, I simply calculate the like whatever value I have in my answer array. Like since it was in binary, so I convert it to decimal, and after that, I simply print it out. So this was the approach, and the one thing to keep in mind is that using this LL operator while you are calculating the powers of 2, and like this is the left shift operator. I think most of you know about this already, so like we won't go through a discussion on this. So basically this was the code, uh, and I hope it's clear for all of you. Yeah, t login. Yeah, that you can say as well. Okay, so I think today we will be discussing only these two questions, and like if you have any further doubts on the other question that are discussed, like that are not discussed here but came in the contest, then you can take that up in your mentorship groups, and I'm sure your doubts will be solved by your respective mentors. And yeah, about the return type that you said, Shaunak Bhattacharya, obviously, like the default calculation of this log happens in double or float. I don't remember it correctly as of now. You can just look it up on the internet. But if I remember, it is probably double. So, like the error you are getting is actually the precision error that you get. Uh, and like this function like log and pow, like they usually come with this kind of precision error in case the argument is greater than 10 to the power 6 or 10 to the power 7. So it is better to use other alternative function, like in case of power function you can most generally define your own power functions, and in case of log, as I said, you can use that inbuilt log2 function. Basically that's it. Thank you guys for joining the meet today. Should I use floor with log 2? Acha, see, you need not to use floor. Like if you typecast it, like as I did, like what I wrote was LL answer equals to log 2 of x, or log 2 of m, or whatever I did. So if you do that, like if you already define the type of your variable that you are setting equal, then you don't have to like use floor or anything like that. That is implicit typecast that happens on itself. So like you just have to define the variable type of the variable that you are setting. That's it. You don't have to do anything else. So okay. So thank you for joining the meet. We will be ending the meeting now. Okay. Bye bye. Thank you.